All right, there's basically nothing new in this video. To prove or disprove an identity, all you're going to do is try to prove it and see if it's different. All right. And we'll demonstrate that with these examples. Example 8. Only got 3 examples in this video. Prove or disprove the following identities. 1 over 1 plus cosine of x. Some of these are pretty messy, actually. The second one especially is a real doozy. 1 over 1 plus cosine of x minus 1 over 1 minus cosine of negative x. Oh, right off the bat, alarm bells. You see that negative x? Even and odd identity. That's a first step you're going to do. Anytime you see that, we're going to use it. And the question is this equal to 2 cotangent of x times cosecant of x? So the right-hand side can actually be simplified probably 2. But the left-hand side's messier. The left-hand side gives us more to work with. So we're going to try to prove it by simplifying and working with the left-hand side. And our first step is even and odd. Cosine is even, so the negative does nothing. A negative on the inside of an even function is useless. It's just like if we had this, right? Negative x squared. Well, you're squaring the negative, it goes away. So I should have given myself more room. We need a common denominator. So this is a little tricky because for common denominators, we have to look at factors. So we actually have to multiply by the whole other denominator. 1 plus cosine of x for this one, and 1 minus cosine of x for this one. Even though they look so similar, and again, this is the algebra coming back to bite you, even though they look so similar, in terms of common denominators, there's nothing. They have no common factors. This becomes 1 minus cosine of x divided by the denominator. Denominator becomes 1 minus cosine squared of x. Ooh, I like seeing that. Why do I like seeing that? Hopefully you know, but otherwise I'll keep you on the edge of your seat a little longer and you'll see why. Times 1 plus cosine of x divided by 1 minus cosine of x squared. So now we have a common denominator and we can combine these fractions. I'm going to write the wrong answer in the numerator. I'm going to mess up my numerator. And I want you to try to find how I'm messing up the numerator. 1 minus cosine of x minus 1 plus cosine of x. What do you think I did wrong here? Pause the video if you need to, because I'm going to say the answer. I forgot my parentheses. We're subtracting this whole thing. So we're subtracting this whole thing, that negative gets distributed. All right, so let's go up here. This becomes 1 minus cosine of x minus 1 minus cosine of x all over. I'm just going to turn it into sine squared. That might be a bad idea. We might need to go back. I don't know necessarily. Oh, yes, I do. I'm looking where I'm going. Cotangent, that's cosine over sine. Cosecant, that's 1 over sine. We should have sines in the denominator. So that's what we're going to do. We have a positive 1, minus 1. Those cancel. And we can collect like terms. Negative cosine of x minus another cosine of x is negative 2 cosines of x over sine squared of x. And we're trying to get this to look like that. And maybe it will, in which case we prove it. Or maybe it won't, and we'll disprove it. So in order to do that, we're going to write this as negative 2 times cosine over sine times 1 over sine. All right, this is still the same thing. But now that first thing's cotangent, that second thing's cosecant. Oh, we proved it. That's equal to the right-hand side. So it is true. We have proven this one. And again, if you're ever in doubt, especially on these prove or disprove ones, go over to Desmos and graph it. All right, the left-hand side, that was 1 over 1 plus cosine of x minus 1 over 1 minus cosine of negative x. Is that equal to the right-hand side? And the right-hand side was negative 2 cotangent of x times cosecant x. Yep. They're exactly the same. Very good. We're going to skip the long one. We're going to do the long one last. Secant of theta plus tangent of theta divided by cotangent of theta plus cosine of theta. Is that equal to secant squared of theta? Prove or disprove? We'll start with the left-hand side and try to get it into the right-hand side. We got a lot of reciprocal functions here. And tangent is also a quotient function. So let's put everything in terms of sines and cosines. Secants, 1 over cosine. Tangents, sine over cosine. Cotangent is cosine over sine. And cosine, cosine is just cosine. So now we have complex fractions. We want to eliminate the complex fractions by multiplying by the LCD of all the little guys. That's going to be sine of theta times cosine of theta. Whatever we do to the top, we have to also do to the bottom. So I have to distribute. On the first one, the cosines are going to cancel. We're just left with the sine of theta. Second one, the cosines are going to cancel. We're left with the sine squared of theta. On the denominator, the first one, the sines are going to cancel. We're left with cosine squared of theta. And on the second one, nothing cancels. We just have sine of theta and cosine squared of theta. So we want to simplify this. Simplifying fractions, you can only cancel if things are factored. So we're going to factor. The top, we can pull out a sine of theta. We're left with 1 plus sine of theta. The bottom, we can pull out a cosine squared of theta. And we're left with 1 plus sine of theta. Ooh, I was pretty worried. I didn't know what we were going to do with that 1 plus sine of theta. Turns out, what we're going to do with it, once it's fully factored, we can cancel common factors. So we're just left with sine of theta divided by cosine squared of theta. This is what we want. We almost have it, right? We have sine of theta times secant squared of theta. Did we mess up? Did we have an extra sign that should have canceled? Or did we disprove the identity? Depends on whether I made a mistake or not. So this is a good idea, checking your work with Desmos. All right, let's actually graph this and see if they're the same or whether they're a little different. So the right-hand side is just secant squared of theta, or secant squared of x. The left-hand side is more complicated. It was secant plus tangent divided by cotangent plus cosine. They don't look like they're the same. What if we change the right-hand side? What if we change it to what we got? Sine of x times. Now they're basically the same thing. So we did do our math correctly. There's this little thing over here. This is it probably has to do with the domain restriction of this function and a little graphical artifact of a little error. So we could dig a little deeper and see where that is, but I wouldn't worry about it for now. Yeah, because there's no actual tracing of this graph. It's just that random point that's sitting here. It might be a removable discontinuity. But either way, we have disproven the identity. Right? This is not equal to secant squared of theta. I'm sure, I mean, not for all values of theta anyway. I'm sure there's some values of theta for which this is true. All right, last problem of this whole section. It's going to be a long one, so strap yourselves in, or maybe go and work on some homework problems and then come back. Part C. I don't even know if this is going to fit. So we have secant squared of negative x minus tangent squared of x divided by tangent of x times 2 plus 2 tangent of x divided by 2 plus 2 cotangent of x minus 2 sine squared of x equals cosine of 2x. And on this one, I am going to give you a hint. It's a future identity that we're not really going to talk about in this class. But 1 minus 2 sine squared of x is equal to cosine of 2x. So we're going to try to prove this. There is no doubt which of these sides is the messier side. And there's a lot that can be done with this. First off, this is what I see. A negative x, let's deal with that negative x. Cosine and its reciprocal are even functions. So cosine and secant are even functions. This exactly becomes just secant squared of positive x. All right, we don't need the parentheses here. Secant squared of positive x minus tangent squared of x all over tangent of x. So we've simplified that first thing. What can we do with the second one? We can't cancel unless we can factor. So let's either factor now or worry about the tangent and cotangent now. It's up to you. I'm going to factor first. We can factor out a 2 from the top and get 1 plus tangent of x. And we can factor a 2 from the bottom and get 1 plus cotangent of x. So yeah, we factored it, and now it's going to be able to cancel. We still have that 2 cosine and squared of x. So we're hoping this is 1, right? Because if this is 1, then we can use the hint. 1 minus 2 sine squared. We already have the minus 2 sine squared. And then that'll give us to the cosine of 2x. So we'll see. Again, a couple different ways of simplifying these, but right off the bat, let's cancel those 2's. So a couple ways of looking at this first one. Let's use a way that I haven't used before. I usually put everything in terms of sines and cosines, but we could use the Pythagorean identity that relates these two as well. All right, what's the identity that relates secant and tangent for Pythagorean identity? 1 plus tangent squared is equal to secant squared. So secant squared is 1 plus tangent squared. Let's try it that way. Let's use something else. Secant is 1 plus tangent squared. And we're subtracting tangent squared. Good. And we still have a tangent of x on the bottom. That's going to be really nice because those are going to cancel. We're just going to be left with 1 over tangent. Very good. All right. And you can either wait on the second fraction or just get going on the second fraction. It's up to you. I'm gonna, let's see, what do I want to do? Let's wait. You could simplify the second fraction, but I just want to show something. They're both fine. Again, there's a bunch of different ways of doing these things. And the reason why I'm thinking about waiting is because if we multiply these fractions together, I'm curious what's going to happen. We're looking at where we're going. Everything's in terms of tangents in this area. So we don't have to put things in sines and cosines. We can. It's a good rule of thumb. Put everything in terms of sines and cosines. Sometimes it makes it messier than it has to be, but it's a very good rule of thumb. So we have one, this right here is 1 over tangent. So when we combine these fractions, the top doesn't change, right? We're multiplying these fractions together. It's just 1 times the other fraction. The bottom is tangent times the other thing. Let's write that out. It's tangent times the previous denominator. But remember that cotangent is the reciprocal function of tangent. Why did I write it that way? Because we're going to have to multiply them together. So now everything's in terms of tangent, which is nice. That's 1 plus tangent of x. When we distribute, it becomes tangent of x plus, well, the tangents cancel. We're just left with 1. Oh, look at that. 1 plus tangent is the same as tangent plus 1. This is just 1 minus 2 sine squared of x. One minus 2 sine squared of x is cosine of 2x. That's equal to our right-hand side. We've proven this identity. You could graph this on Desmos. Both sides are going to be the same. Here we go. You did it. 9.1. Go through the homework. Let me know if you have questions. Good luck and enjoy.